Hi, everyone. This is Dr. Mina Blazey. I'm going to give you about a 10-minute overview of the next generation science standards features on what you can actually do and find. I'm not going to give you a lesson today on how you can actually perform the standards and show the content in the classroom, but there are features that maybe you need to just have a revisit if your state in the United States uses the next generation science standards. And you will see that there are search features. You have the standards where you can read the standards, appendices, understanding the standards and developing and how the standards were developed. Then you have instruction and assessment, evaluating NGSS design, understanding the design, the quality of the units, and then the assessment resources. And then you have planning and communication, state and district implementation, and communicating about the standards. Today, though, I want to go over some of these features and we will get into the search features. But before I do that, just in case you didn't see my YouTube reel or my YouTube short, let's go down to the three dimensions of science of learning. You have the three dimensions here. You have the science and engineering practices, the disciplinary core ideas, and the cross cutting concepts. These dimensions were meant to be influenced in the classroom and fully integrated. When we talk about integration, we're talking about STEM integration, science, technology, engineering, and mathematics. Really looking at what the STEM map looks like. And NGSS did a really good job of doing this. However, depending on what your level of science content or engineering background is, this can feel overwhelming. So let's dive into the cross-cutting concepts. The cross-cutting concepts are a place where you help students integrate the domains of science, and they're right here. Physical science, life science, earth and space science, and the engineering design. And then you have the science and engineering practices. These practices are what scientists do to investigate the natural, the physical world, and then what engineers do to design and build systems based on the content that students have learned or based on the content that they already know and they are fully integrated. So it allows students to have an inquiry based or information around what that looks like from content and what you can do differently in order to change the world. The example I like to give is flight in space. You understand that there are unbalanced and balanced forces, but we have an airplane, and how does that defy gravity? But engineers were able to design airplanes in order to defy gravity. And then we have the disciplinary core ideas. The disciplinary core ideas are the idea behind the science that it's very specific. Even though it says broad importance, it's very specific in the idea that we take those those four domains and we say what are we doing specifically with physical science, and what is the performance expectation or the standard in order to drive that instruction for the classroom. And it may be over a day, it may be over weeks. What's that unit of study? So to do that, we go to the search. Now, you can search right here, but I like to go and just tap on the search button. And the reason why I like to do that is because I get a bigger perspective when I'm doing my search. And when I see this, I see it, there's a lot here. There's some things on the right that I want to show you. And then there's some things on the left. You can still do a key search. You can still search by display only, but I would recommend that you go down here and then maybe click or select a grade level. You can select a grade level. You can do specific grades. You can do it by grade span, K2, 3, 5, middle school, high school. You can do it by the science and engineering practice, and you'll notice that it's very specific. Science and engineering practices are either asking a question and defining problems, developing and using models, planning and carrying out an investigation, analyzing and interpreting data using mathematics and computational thinking, and so on. And you can look at those. And the other place that you want to go to next, you'll see disciplinary core ideas and discipline. Again, discipline are these specific areas of science and engineering. And then we have the disciplinary core ideas, and you'll notice that they're broken out. PS, for example, is physical science. And if you go down a little bit farther, you'll see LS, life science. And then they're numbered based on whatever grade level or content is being explained. And then you also have the cross cutting concept. Cross cutting concepts integrate the science and engineering practices and also integrating the sciences together. So, is there a pattern? Is there cause and effect, scale, proportion, and quantity? Systems and system models, engineer and energy and matter, structure and function, for example. And you should know what those are because it can, you feel like, oh my gosh, there's so much science going on, but this will tend to organize it for you. So if I were to click on this kindergarten physical science, second grade, that's what that says, and it's standard one. And this one actually is in a grade span of kinder through second grade or just kindergarten. And you get to see, you can either download this PDF or you can look at it on your computer. And when you see this, you see a performance expectation. This is the standard that you're looking for students to master by the end of whatever time frame that is. However, you'll also see that you have the S&Ps, the DCIs, and the cross-cutting concepts. Note that I did just abbreviate those. And the you want to take a moment and process this. This is a lot. But Kinder, I like to look at the small things first. We're looking at cause and effect, just cause and effect. And then if you look at this standard, it's plan and conduct an investigation to compare the effects of different strengths. Remember, science and engineering practices. And this is specifically what that is. And then it tells you you're planning and carrying out an investigation. But this is what students are to know by the end of whatever that time frame is. And that's specifically a different strength of different strengths of different directions of pushes and pulls on the motion of an object. Now, lots to go over, but you notice that its disciplinary core ideas are covering forces and motion, types of interaction, and relationships between energy and forces. And it gives you a bit of an explanation under it and what that looks like. And these are interactive, and you can click on them. And then underneath, it gives you the English language arts standards, like what are students going to write about? I love this because you're writing and now integrating the language of the discipline and writing about it. And then it gives you mathematics standards. And typically, MP means mathematical practices. What are students going to think about? They're going to be reasoning abstractly and quantitatively. And then you have specific standards. Now, there's a difference between those, but that's a whole nother lesson. But I wanted to point something out that I talked about in the YouTube short, and that is that related evidence statement. And I want to select that just for a moment. And the reason why I want to select it is that you saw that performance expectation, and at the bottom it gave you the Common Core standards for English language arts and mathematics. However, this opens up and it's slightly different at the bottom. And a lot of educators don't know this. So you still get the same performance expectation. Notice it's not interactive here anymore. If you were to go back, it is. But down here, the evidence statement is giving you a phenomena. Now it's giving you a rubric and expectation of what students need to know by the end. So observable features of the student performance by the end of the grade, not in a specific time frame. So not telling you when the student will understand this and how long it will take. And there's this idea that you teach science and engineering in isolation, but when you fully integrate them, it goes into a student's long-term memory. And notice that it says identify the phenomenon to be investigated. Then it tells you identify the evidence to address the purpose of the investigation and then plan the investigation. And while this seems overwhelming, if you take a step back and plan it. Now, if your school district has a curriculum that goes along with the next generation science standards, this will not be as overwhelming because something that you can do is integrate the reading and the writing, the English language arts and the mathematics at the same time. And you literally can expand what students are learning in a shorter amount of time because you're giving them the ability to integrate their learning with specific content in science and engineering. And I will go back quickly so you can see that this perspective was a little bit different. And then if you go to this perspective, at the bottom, the evidence statement gives you somewhat of a rubric in order to help students achieve what they need to achieve. I hope this video was helpful for you. Please click and subscribe. I am going to be going over this over the next few months so that I can help you in the classroom, especially if you're kinder through fifth grade. And if you're a middle school or a high school teacher and you really want to integrate and understand how you can get students to not just memorize, but to fully learn and understand it so that they can problem solve through what they're learning and to use the information, regardless if they go into the STEM fields, they can learn the problem solving skills. Thank you so much for watching. I do appreciate you.